Has been started. Okay guys, welcome to the third day of this internship. So we are doing very good so far. We learned various things. We learned about command line interface. We learned about basics of Python. Now we are ready to jump to something else. So today we are gonna continue our basic sessions. So today we are gonna talk about GitHub, how to use GitHub, what is the power of GitHub, how can we implement it in our programming, in our coding, and how can we set a collaborative environment by using that. So you will love to understand it, I hope. And then after that we will be talking about LaTeX. LaTeX is a very beautiful scientific language. So it is basically a document writing script. So you might have came across already this, because I have seen some of your CVs are in LaTeX. I could identify it. I don't remember exactly the name of the participant, but I have seen there was some LaTeX CV. So I liked it very much. So some of you already know how to work with LaTeX, but still we are gonna touch the base, right? So before going to GitHub or before going to LaTeX, let us start with some basic shortcuts about VS Code. Okay, let me share my screen, which are very helpful. So I always start with basic and I build my house with that. Like I make my foundation strong and then I work on the tedious problem. Okay, so let us talk about the shortcuts. Okay, to demonstrate about shortcut, let me open a comprehensive code. Maybe I can open my code, okay, because it will be very simple if I give you demo on this code. So let me just open my code. Okay, so I went there, code dot, that means I opened it in the current directory. Okay, so this is my code. It is very comprehensive, around 10,000 lines or 6,000 lines, I don't remember. Okay, so it has like a lot of things. Now if whenever I am playing with code, whenever I'm playing with the extensive code, I have written it with all sort of Python features. Now you want to edit it again and again. This is how you learn, this is how you improve your code, this is how whatever you want to execute for your code, for your physics problem, right? So let us say I made a variable like interface for some purpose. Let us forget about the purpose right now. So for some purpose I created this variable interface, right? And I want to change it throughout my code. How will I do? How would I do? I will just use search interface of VS Code, right? I will write interface, okay, and it will tell me all the instances where interface has been written, okay, and I can just click there and I will replace with interface. Okay, you guys are smart, I can replace it with anything. I just don't want to mess up my code. Okay, let's just for the fun I did interfacey. Okay, so here there are two options. One is the first one, I can replace only one entry one by one, and this is replace everything at once. Okay, so I did interface, I did change from interface to interfacey, everything at once. Now since this is a dummy variable, my code will not create any problem, I hope, if it is not linked to any other code outside this code. Okay, so it should not create any problem because it is a dummy variable. I will more talk about dummy variables. Okay, so now this is what I wanted to show you, which is very simple. Okay, let's do something else. Okay, let's get things straight. Now this thing is very important. Sometimes we don't want to change that particular word throughout the code, we just want to change it in a particular section, right? So what I will do, I will click on this guy here, this icon here, right? So first select this and then I click here. Okay, when I click first select this, when I click here, it will only show whatever I wanted to find. It will only show in that particular section, and it will only replace that thing in that particular section. So it is very, very important when you are dealing with extensive codes, okay, which you are going to do in few weeks. Awesome. What else? So we have this button here which shows us the current directory wherever we are right now, and it shows all the codes, right? And now if I want to open some code, I can scroll through it, I can create it, I can click on it and it will create open it. Now what is the other way? If I remember what is the name of my code in this directory, I will just go there and I will write the name of that code, right? It will just open it. It is fast. So when you are familiar with your code, you just write, okay, I need this. So it is fast. It is way faster than going there and looking for all those things. Okay. What else? So in VS Code, we also have this extension options. So you can install any extension you like. You can install C++ extension, ChatGPT, or Docker extension, or Jupyter extension, GitHub Copilot, anything you say, whatever is available, modern Fortran. So what extension does basically, it provides you extra power. For example, if you are doing C++ or Fortran, you are writing your code in Fortran. So how would editor know that it is written in Fortran? How will it color code it? What do I mean by color coding? See, here it is color coded. Parser has some blue color, it has some other color. So it helps us understanding, it helps us differentiate between different parts of the code, right? So it is very visually appealing, very organized, very arranged. So VS Code by default, it has all these color rendering settings, but still sometimes we need, for example, for Fortran, we need modern Fortran extension. If when we install modern Fortran extension, it gives VS Code special powers that it is now easier for Visual Code to display it, right, with color coding. What else? What is this? Testing, make file, overleaf workshop. You can also integrate overleaf in it, but I don't like it. I prefer overleaf on the overleaf website, like LaTeX on the overleaf website. And then we have windsurf here, which is a AI. I embedded an AI which suggests me the next line, right? So when I click here, please suggest me, otherwise, okay, it is suggesting something. Okay, let me click here. So whenever I am playing with this code, it does that. Okay, let me do this. Okay, it is suggesting me something, right? It is whatever it is trying to comprehend from my code, it is suggesting me something, and it is very helpful. 90% of the time it can read my mind, what I am trying to say. So I will not recommend you to try anything for now. I am just, for the knowledge purpose, I am sharing with you. Don't do it yet. Okay, am I sharing the screen? Okay, so don't do it yet. Whenever you are master, whenever you are at intermediate level, you know how a language work, how a code work, then you try, you start using these tools. Otherwise it will hinder your creativity, and it will hinder your coding brain. So this is a tool, so do not make it like intellectual thing. It is just a tool. Okay, then what else we have in we have this thing as well. So you can also link your GitHub to your VS Code, and using this graphical user interface of VS Code, you can just pull your Git repositories. So I don't like it. I prefer terminal. So it's up to you if you want to do that here or there. So we will talk about that in a bit. Okay, now what else? And there is another very powerful thing for code editing. For example, I am playing with my code, and I want to change some of the names. For example, I don't like this name cpbl. Okay, it is a file name, and I thought, okay, I changed my output file in my Fortran code. Now I want to change this name here, obviously. So what I will do, so this is not here only, it is at multiple places, right? One way is Control F, right? You can do that. Other way is I don't want to do control F, I don't want to select and then do this. I don't want to do that, right? What I can do, I go here, I select this guy here and I press control D. Okay, command D. It is in my Mac, it is command D. I don't know for Windows, you have to check. So when you do command V, command V, command V again and again, every time you click, it is selecting the next word which I am looking for, right? And when I do that, you can see the cursor is highlighting, and when the cursor is highlighting, I can delete it altogether, and whatever I will write here, it will just write here. So it is very useful when you are dealing with extensive codes. Okay, so that was one thing. About what else I wanted to tell you was command option down. Okay, there is another shortcut, command option down. For example, if I click here and I put command option down, okay, I press command option all together, then I am pressing command option down one by one. So what it will does, it will select a particular column here, right? This column, the whole column. So what is the column number here? Oh, since we have selected it, so I have my cursor here, it is column 46, right here. Yeah, this here, line 174, column 46. So I pressed command option and now I'm pressing down button. Come on, why it is not happening? I just did it. Yes, so command option I clicked and I clicked the down button. Okay, now the cursor has been become a big cursor. You can just edit all these all together. You can just go back. Okay, this is the power. You can change multiple lines at once. So what else? One more thing, so this is the command option and down key is restricted to a particular column. I don't want that, it is restricting me, right? So I want to be more creative. So what I can do, I can use option plus click inside. So what I can do, I clicked here. When I clicked here, for example here, I press option on my Mac and I can move my cursor anywhere. For example, I wanted to change multiple words, multiple different words to something else, right? So now my cursor is alive at various places, so I can delete this altogether, I can rewrite this altogether. So I am deleting it and I am doing something crazy, right? Whatever I wanted to write here. So this is about basic shortcuts in VS Code, which are very helpful, very helpful. So you will get to know about that when you really start practicing it. Okay, so I like them very much. You can also explore more shortcuts. I think if you go, there must be something. Right now I don't remember. So you can just explore all these options and you will find the whole shortcut list. I think this is the thing. Yeah, you can go through all these things if you have time, but I have told you basic shortcuts, right? So far so good. I don't need that. Okay, I can just let it go, and I want this here. Okay, okay, so far so good, right? Okay, let's talk about GitHub. Okay, it's very interesting. I like GitHub very much. So okay, for that, have you created the GitHub account? If anyone has not created, please do this. Everyone has created, very good. What about Overleaf? If anyone has not created, everyone has created. You guys are very good. I don't have to, you know, I thought the first week will be very tough, like I will be struggling with all the installation, and that is the toughest part. But you guys did very well, very well. I liked it. Okay, so GitHub. So in your GitHub, you have your account, right? And you have your profile. So this is your proof, how your profile will look, and your collaborations will appear here, and the repositories I am particularly interested in. Okay, so let's create a new repository. So I press this button new, and then I write some name. Okay, let's do test. Let me just write it what was that, SICNAP 2025. Okay, so I did that. I did repository name. I wanted to make it public for the time being. Description is optional. I don't want to add readme file. Okay, I can do git ignore. I can do git ignore for database, but you can select anything, it doesn't matter. Then we have license. License is fine, I don't want anything right now. So let me hit create repository. So when I created a repository, so it basically git created repository for me. Now, so there are two things. One thing is local, one thing is on cloud. Right now I am in cloud. I am in GitHub database online somewhere in the cloud. I don't know where. So what I wanted to do, I wanted to make this repository available in my local machine. How would I do that? So this is an empty repository. So there are several ways. I use HTTPS, which is very simple. So what I will do, I will hit this code button here, and then I will go here. I will click this link. Okay, then I come back to my terminal. I don't need that. Let me clear everything. Okay, so when I clear everything, I will just write git clone. Okay, so when I do git clone, it basically cloned a repository which I created on web to my local machine. How do I check it? When I do ls, I see SICNAP 2025, which is a GitHub repository. So I wanted to go inside that repository. So I will just write SICNAP, and I am inside the repository. So there is nothing for the time being inside the repository, so that's why it is empty, right? So we will fill it with some things. So you can basically create a Vim file here. You can do anything you want. So before going further, let me just open the deliverables. Okay, so that I have so I have something to follow, right? Okay, so far so good. So this is how we can clone. Okay, but okay, I missed some basic information about GitHub. So what is a version control? Why we are using GitHub? So version control is a system that records changes to a file or set of files over time so that you can recall specific version later. Okay, so for example, you are working on a file .f file, .c file, cpp file, anything, .py or .npynb. Okay, so in that cases you are regularly updating your code. Whenever you are regularly updating your code, you are changing, you are creating like ample versions of it. So in that case, you sometimes the changes are meaningful, sometimes they are not. Okay, if they are not meaningful, you don't have to track it, but whenever you are done with it, something significant, and you wanted to save your progress, or you finished one project, you wanted to save your progress, then you can push that changes to Git, right, and create a new branch of it, or create a new tag for it, whatever you want. Or you can also copy that thing to some machine. So let me just tell you one thing, I can show you actually. So this is these are the same code, the replica of same codes. So little bit of changes for every of them. So I don't do branches, but branches are very good. I will answer you, Harish. So branches are very good, but I don't used that concept so far. Okay, so these are multiple folders with the same name. They are basically same. They have some minute changes. So one way is you can create a copy of your folder and organize. Other way is you use Git. I prefer Git whenever I am doing changes in one project to track. If I have some other project, like I have to create a branch, I prefer making a folder for now, but I wanted to switch to branch. Okay, so let me just read what you want to say. If we make any changes from the local machine, would it affect the cloud? Yes, it will affect if you commit it, if you push it. We will do that. Okay, what GitHub is, it helps developers to track and revert changes. Okay, we will see how. It also helps you to collaborate with others in a real time. That is also a very powerful feature, and it also helps maintain code history. I will tell you how. You can see it very clearly. So Git is the most widely used version control system. GitHub is a cloud-based hosting service that lets you manage Git repositories online. So repositories are folders, like fancy name for the online folders. Okay, so first of all, I told you to create a GitHub account and click on sign up and follow all these processes, which is very simple. And once you are logged in, you can create join repositories or repos, in short form, and clone them into your machine. We just cloned one thing. Now this is very important. The second thing, GitHub is not accepting passwords for authentication anymore. So you have to generate a personal access token, okay, for push access. Like for example, you did some changes in your local machine and you want to push that change to the cloud. What will you do? How will you do? You have to do git push, and for that you need some privileges. And how do you tell Git that, okay, I am the one, I am the admin, I am the person whose account is associated with this push, this particular repository? So for that you need your username as well as your password. Okay, so the password is no longer working. So GitHub has replaced the password with personal access token. Maybe you can log in once through password, but after that you need personal access token. So how do you do it? You click setting, developer setting, personal access tokens, generate new token. Okay, let me show you how. So I am in my GitHub. I click here, and when I click here, okay, this is hindering me. Okay, so I put push settings, and when I push setting, I scrolled up and there is a developer setting. When I click that, so there is a personal access token. There are two tokens, so you can use token classic. Okay, if you can choose either of them. So you can generate new token. You can also use migrant token. So I have generated a token and I have put it as a no expiration date. Okay, and do not show this to anyone. Whosoever this token, he or she can access your Git repositories. Okay, where is next? So make sure you copy your token and save it somewhere securely, because you will not be able to see it again. So you will use this token as a password when pushing your code. Now installing Git, you can install Git on desktop. There is a dedicated desktop app which is GUI based, so it is very easy. You just have to click buttons. So I don't like it, but still if some of you like it, you can do that. Linux, you can install Git. Oh, in Windows you can also use Git terminal. When you install Git for Windows, there are two options. One is GUI based, one is command line based. So you can use either of them. And in Linux, what you can do, you can update your system first, sudo apt app update, then you install Git. Okay, and in Mac you can either use homebrew or you can use Xcode. So I use homebrew, install Git. So when you do this and let us say I have installed Git, how do I know? I just write Git. When I write Git, okay, I can see it is showing like the usages of Git, so that means it is already installed. What else? then you have to configure your Git for the first time. How does it know you are the person who is using Git in your terminal? So you basically associate yourself to the terminal the Git installed in your terminal, right? So how do you do that? You execute these commands: git config -- global user.name, and you put your username in between these quotes, and similarly you put your email, right? So this ensure your commits are correctly attributed to you. Now common git commands, very simple. So initialize a repo git init. If you want to create a repo from your computer, then this is the process you have to follow. If you create your repo on the web like I did, you don't have to follow this. You just do git clone, and the HTTP link I copied from the web. So I will just go to my terminal here, and I do ls, there is nothing, okay, and I go out, and if I do this, so I wanted to copy my py code to SIC this, right? So I copied, I go to this, I did this, okay, I copied my Python code with some basic Python code from the previous folder to the new Git folder. So when I did that, and I also did list, I can see my Python code is inside my new repository, which is a Git repository now because I created it, right? Now what I have to do, I have to do git status. I have to check whether it is really inside my new folder. What is the status of my git here? So git is saying okay, let me clear that again to clear the mess, and I did git status again. So what git is telling, that I am on the branch main. So what are the branches? So in a repository we can create multiple branches, like one code different replicas, right? I am on a main branch right now. I will tell you how to create a different branch. Okay, so right now I am on a main branch, which is a by default branch, and your branch is up to date with origin main. That means I am connected with the cloud, okay, and it is up to date. So it has no conflicts, but there are some untracked file. What does that mean? That means git is not tracking those files. It is just in my local machine. It is not communicating with the cloud. So the py underscore code.py, okay, let me just show you what is that. So this is my code, okay, I just created it. It's very normal code, and I run it, and it is displaying something. Okay, it is displaying whatever I have written. You guys are master now, you know how it works. So so I pasted this code here, and I checked, okay, now git is suggesting me, git is telling me there are some untracked file whenever I am pressing git status. Okay, now this is on my local machine. I want to push it to my cloud so that I can save it somewhere, and I can also collaborate with someone can also pull it. There are two things, push and pull. Pull means I am pulling something from the cloud, push means I am pushing something to the cloud, okay, and when I push, other guys can also pull the same change. So it is like a collaborative thing, we will get to know. Now I did git status, it is showing some untracked file. What is next? Okay, now I did git status. Now I want git to track these files, okay, so that it understand every time I am making some changes, git should track it. So how do I do that? There is a command git add, okay, when I do git add and I write whatever file name I have and I press tab, it auto completes, and I hit enter, okay. So I added a particular file which I am interested to push that into the cloud. So this is one way. Other way is git add, you can see here space dot. When I do that space dot and I hit that, it will push everything, not push, it will add everything you have in the folder. If you want to add particular file, then this is the command. You have to do it multiple times, and if you want to add all of the changes, all of the files, then you have to do that. Okay, git add dot means the current directory, whatever you have in the current directory, just push it, just add it. What else? If you want to add all your .py files, so you don't want to add all of the file, all of the different .f, .py or .cpp, all of, but you just wanted to pull a particular, just wanted to add a particular format file, for example Python file, then you do git add star.py. So it will add all the Python script to the repository. Okay, local, they are still local. Now we have made one step, we have added our desired files to git, we are still in the local machine. Now when I do git status here, I do git status. Okay, what is it saying? It is saying there are some changes now to be committed. Okay, so before that these were untracked, if you remember. Okay, I cleared that screen. Before that it was untracked, it was appearing as, oh here it is. So untracked file, but now it is green, that means it is ready for commit. Okay, now what, how do I commit it? What is the syntax for that? So stage files for the next commit. So basically we staged a file, so that means whatever we did just, it is called staging. So whenever you press git status, it will show you whether the files are staged, modified or untracked. Untracked are the file which we just added, and if I add this file, if I change this file, it will show it has been changed. We will talk about that soon. And then we have modified, we will also talk about that soon. Now I want to commit this change. How do I commit it? But before that, let's do one thing. Let me just add something. Let me just add one more day. Monday, all the days are covered. Let's create a new day, holiday. Okay, holiday cloudy. It doesn't matter, sometimes it doesn't have to make sense. I am just showing you for the representation purpose. Why it is complaining? Because there is no comma. Okay, so I did this change and I went back to my git. Okay, I can actually do that here, I don't have to go again there and there. So what is that? cd ls, and then I have git, then I have this, then I have cd repo, this cd sin. Okay, so I am here, I clear my terminal, so I can do side by side, I don't have to go to that terminal. So what I was doing, I did git status. Okay, so git status, now you can see it is telling me there are some changes to be committed. Okay, let me do one thing here, git stash. Okay, nothing to be committed. Okay, git add, what was that? Git add Python. Oh, it's basically deleted that because I stashed it. Okay, let me do one thing more. So I go outside and ls, I copy my py again and I pasted it in SIC. Okay, and I went to SIC. Okay, and I did ls, I'm here and I am doing git status here. So when I did git status, it is showing there are untracked file, and now I copy pasted it again. Okay, like this. So I just made something funny, it should not be logical. Okay, when I do that, it is again saying there are untracked files, so there are some changes, but it's not highlighting the modification. Now what I will do git, did I add it? Not yet. So I did add git add dot, when I do that, it basically added this file. So now it is saying changes are to be committed. So let me do a change here again, and when I do that, okay, so it is still saying there are changes to be committed. Okay, anyhow, now I want to commit this. If I want to commit this, what is the syntax? The syntax is git commit -m, when I do git commit -m and then I write in inverted comma, I basically what I have to write here, I have to write something meaningful which is related to my changes. So since this is a first commit, I will just write I created a Python code about weather, right. So I created a Python code about weather. So when I did that, it basically committed this change in my local machine, right. So what is it is saying, one file has been changed and there are 27 insertions because there are 27 lines. Now if I do git status again, okay, so it is saying your branch is ahead of origin main by one commit. What does that mean? That means in my cloud I am behind one commit, because in my local machine I have already committed one thing, I made some changes and I committed something, right. Now I want to push this on the web. How do I do that? So for that you have to add your if you are doing it for the first time, you have to add your repository. You have to link your repository and then you can push. Okay, so I can just try git push and it is asking me for my account, okay, and it pushed. So you can see what happened. When I did git push, it linked to my account because I have already done these processes here. If you are doing it for the first time, you have to follow these processes, and basically what you do, you push your local changes to the origin main. What is origin main? In the cloud. Okay, so now what I can do, I can do git status again. Now there is nothing to commit, okay, because I already committed and it is on the cloud. Now what I can do, I can go to my cloud. Where is my cloud? Yes, here. So I can go here and I can go to my repositories. If I go to my repository, okay, I click here, so it will show the changes here on the cloud. So I made these changes on my local machine, right. You observed that. So I made these changes on my local machine, but when I pushed it, I can see it here. So now it is in the cloud. Now after one day you want to update your code, right. You want to update your code. What should you do? If you want to update your code, what will you do is, first of all, whenever you want to update your code, like you are done for the day and you don't want to play with your code anymore, you just push your changes to the cloud. Now what you want to do next day, you want to start fresh. So the first thing you will do is git pull. Okay, this is very important. If you don't do that, there will be a lot of conflicts. Why would there will be a conflict? Because some of the other collaborator might have pushed their changes to the origin, to the cloud, and whenever you try to push your changes without pulling, that will create a conflict because the files will not match. Okay, then will create a conflict and you have to solve it. That will take some time. Okay, and therefore whenever you are working the next day, it is very good. If you are not with any collaborator, that is fine, you can do without git pull, but if you are working with collaborators, they always do git pull. Okay, now I did git pull, it is already up to date. That means whatever is in my local machine, it is in sync with the cloud. Now what I want to do, I did git pull, I do it again. Okay, it is saying already up to date. Now I wanted to do something else. Okay, what I can do, I can write stormy if weather has hurricane. Okay, but there is no option there. Okay, I have to change that here. Let me do something. So I did sunny, I did weather to sunny, so it doesn't mean anything, don't think logically here. So when I do that, now I did git status. Okay, when I did git status, it is not changing. Maybe I'm, oh, now I get it why it is not reflecting, guys. Okay, can anyone tell me why it is still showing nothing? Because I changed my file and it is showing nothing here. Can you point out the mistake, guys? Because I am editing a wrong file. Anyhow, it happens sometime. So it should be inside this, and this is the file I am interested in actually. Yes, I was editing the wrong file. Okay, so this is the file. Now I am changing it. Okay, git storming to git sunny. So when I changed it and I do git status, so it is saying, okay, I modified my Python code. So what is the difference? How do I know it? What changes I have made? I will just use git diff. So when I do git diff, basically git compares your local code with the cloud, and it is telling me that I deleted this line and I added this line. So it is showing you, it is comparing both of the code, and it is showing you like I deleted stormy. I basically changed it to stormy to sunny, but for git I changed the entire line. I deleted the line with stormy word and I added the sunny word there. Okay, now I changed my code. I did a lot of changes in my code and I want to push it again. I want to update my repository on the cloud. How would I do that? I will do git add, and again I will do add dot or add file name, whatever you want, and when I do git status again, it is showing me it has been modified and the changes are ready to be committed. Now I want to commit it. How do I do it? Git commit m, and let's do this, and I put some meaningful caption here. I did some meaningful change. Okay, change. I did some meaningful change. So when I do that, it basically committed and one file has been changed, one insertion has been done and one deletion has been done, and then I will just do git push. So when I do git push, it basically pushes my local changes to the git cloud. How do I see that? I have to go to my web browser again and I go back to my repo. Okay, I reloaded it. So I can see it is showing the latest commit here. I did some meaningful change. When I click that, okay, the commit, it is basically telling you what did I change. I deleted this and I added this. So this is very helpful to compare your statuses of the code, like what changes you did before and what changes you did today. Okay, so it will help you in a longer run, because it will help you. Okay, let me show you something. It will be helpful if I show you extensively. I go back. Okay, I open not SICNAP, overview, maybe projects, not projects. I have a repository linked. I have to find it there. CMF mp3 GitHub. Oh, it is with my GitLab, not GitHub. Wait, there is one repository here. There it is. Okay, when we talk about this repository, okay, so you can see this is a repository and it has 357 commits. So when I hit commits, I can check all the commits like one by one, and if I click on this particular commit, you can see there are 635 changes have been done. So there were 617 lines which were deleted and 635 lines which have been added. So it is very helpful to track all these changes, right, with the help of Git. Now what else? Okay, now there is a also very important very important feature of Git, which is Git stash. What is Git stash? What is it is used for? If you want to, if you did some changes, mistakenly, or you change your mind later on that I don't want to make these changes. So how do you do it? Okay, you did some changes and you did git status, and you see, okay, there is a modified file, but I don't want that modified file. How would you do that? How would you revert it? So you will do git stash. So it is used to temporarily save uncommit changes without committing them. This is helpful when you want to switch branches quickly, or you need to pull updates without losing your local edits. Okay, for example, okay, let me do a change here, cloudy to something cloud. Okay, so I did this, and when I this git status, it is showing the python py_god.py has been modified. Now I don't want this change. Okay, so I will do this git stash. So when I do git stash, okay, you can see it basically undo my recent change. It changes it from cloudy to cloud again. So basically whatever I tried to modify, it reverted it. So this is very important. What else? Basic commands, I talked to you about git stash, and you can explore these git stash options. Now branching, let me tell you about branching. It is also very helpful. For that I have to go to my repository. There is only one main branch. So this guy is my collaborator, so he has created this repository, and I can see that. So let me go to my repository, and you can see there is an option like main, which is a branch. It is showing me there are one branch and 0 tags. So in the branch you can see how many branches are there. There is one branch which is default. Okay, and right now I am in my current branch, and I want to switch branches now. So first of all I will see what is my branch right for the time being, which is I will just have to write git branch, and when I write git branch, it is telling me, it is showing me all the branches I have in my repository, and right now I just have one main, and star means I am in current branch. Okay, main branch. Now I want to create a new branch. How do I create a new branch? I have to write git branch, and then I can write anything like new branch. Okay, I created a new branch. Now I want to see how many branches I have. I have two branch now. One is main and one is new branch. Now I am done with my current branch, and I want to do my work. I want to start my project in a different branch, so that I don't mix my projects, right? But if you do that, you have to be careful. Every time you start a project, you first check in which branch you are in, then you do the changes. Now I am in my main branch, and I want to go inside my new branch. How would I do that? I would write git checkout new branch, right? When I do that, and I did git branch again, now I am inside git new branch. This is how you switch your branches, and now whatever I will commit, it will be updated in my new branch. Okay, let's go to my git account again, and I will reload that. Okay, and now it is not updated. Maybe I have to commit it. Okay, so let us commit it. Let us do this thing. Git add star. Okay, now I do git status. So it is on my new branch, nothing to commit, the work tree is clean. Okay, and I did some changes here. Let us do some changes. Go for a walkthrough. I just deleted it, and then I did git status again. Okay, it is modified. Now I do git add which is already done. Let me do it again, doesn't matter. Then git commit f testing branch, okay, and then I do git push. So when I did that, it basically pushed my new comments to a new branch. Let us see whether it is reflecting here or not. Okay, it is reflecting, right? It is reflecting, very good. So you can see there are two branches now, one is main and another is new branch. I committed my latest commit, what are the active branches where I am currently working, and I committed my latest commit in the new branch. Okay, this is how you play with Git so far. Now what else? I told you about Git branch, I told you about Git checkout, I told you about Git diff. What else? Git keep. So I'm not gonna show you here, I will just tell you the motivation behind it. So sometimes you have an extensive code, you have like different parts of your code divided in different Python or whatever programming language script, and it has like objects related to that, executable file related to that. You are not interested in that thing, you are not interested in objects file, you don't want to track it. For example, okay, let me go to my folder again here. Okay, if I do that, so this is my source code of my work. See, object Darwin. So these are the file. Whenever I run Fortran code, what happens basically, the compiler changes into some object file, okay, and then it changes into some executable file. But in actuality we don't read it really, we just need the source code, we don't need .o, we don't need .exe to save it somewhere, we don't need that, and they are very heavy like in MBs. So I don't want my Git to be, you know, fulfilled with all those things. I want to use as much as less memory on my Git. So what I will do, I will not allow Git to add those files to the cloud. How would I do that, and how would I do it otherwise? If I want to keep something in my Git, how would I do that? So there are two options for that. One is git keep. So in a folder which is meaningless for you maybe, but you still want Git to track it, then you can use that. You can create a folder, you can create a file in the folder with the extension .git keep, and if you do that, every time you are doing git add, it will keeping that folder. It doesn't matter whether you are adding it manually or not, it will automatically keep that folder. And next is git ignore. Git ignore is again the same motivation I was giving you. We don't need temporary files, we don't need .log, we don't need .temp to track, we don't need .o objects file to track, we don't need cache file to track, we don't need data file to track. We don't need that because it doesn't mean anything for us whenever we are working with the programs. We can download our repository, we can clone, we can update our repository, and we can run it the same way it was running before. Okay, so if you want to untrack those changes, if you want Git not to track those changes, you can just in that particular folder you can just create a file with .git ignore extension. Okay, last but not the least, about let's summarize this what we did so far. So we basically created a repository on GitHub, like the account itself on the cloud. Then I cloned that repository on my local machine. When I did that, I did create that repository in my local machine. Okay, I cloned it. Then I saw git status, I did git status, and I checked whether there are some file changes or not. And after that I did git add in whatever file I wanted to add, and it basically staged the changes. And then if I wanted to commit it, I did git commit -m and meaningful message, it basically commits that change. And then last but not the least, I just pushed it and uploaded it to the GitHub, and in the next time we can also git pull it. So what are the tips for the best practices? So these are very helpful points. Whenever you are writing commit messages, always be meaningful. right? Always write meaningful. For example, see, I did some significant change here, here to my commit. Let me go to my repository. Okay, so there are 2 branches. How many commits are there? 3 commits. So I will just click it. So I did 3 commits here. So guys, whenever you are doing commits, you will not going to remember what you actually did, right? You are playing with your code every day, so you don't remember all the changes you did at that point of time. So how would you remember it? One way is, if you have no meaningful comment, you have to click and then have to see, oh, what did I change? You have to track all the things, then you will remember, okay, I wanted to do that thing, that's why I did this commit. So this is not a good way. The good way is you explain your commit, you put some meaningful word there, so that whenever you see that, you know, like, what is this commit about. And the second thing is, commit often but with purpose. Don't commit it like, okay, I did one change and let's commit it. No, not do that. If you have significant changes, like you are done for the day, let's commit it. Okay, and it also helps you create a backup. You don't have to be worried about like cloning it somewhere to the cloud. If you have Git, you have a backup always. Okay, you need a backup for any scientific computing, and obviously you need for any other things nowadays. And third is, as I told you, you have to pull changes before pushing to avoid conflicts. So make your habit, check branch, check, first of all, check branch, the current branch wherever you want to work, and then pull the changes there, right, before pushing. Otherwise there will be conflicts. And you can also use branches for new feature and experiments. So far that was the about Git, and I would like to emphasize the difference between git add, git commit and git push. So they are kind of confusing. Why we need 3 different things? So there is a difference. So git add, what does it do? It basically add a local file, a file in your local machine, and when you do that git add, it basically stage your changes. You are telling Git which files or changes you want to include in the text commit, in the next commit, right? So the analogy is, mark these changes to be saved. This is just one step. Just mark it so that I can compare. If I mark it, I can compare my local thing with the cloud, and I can do git diff, right? That is one thing. Now git commit, it basically records a snapshot of the staged changes in your local Git repository. So when you do git commit, it is still in your local machine, whatever changes you have done, whatever the staged changes are, but you are saving a version of your project with a descriptive message. So everything is your local machine, but it is with some descriptive message. It is something substantial now. Now what is the analogy? First in git add we mark those changes, now we save those changes. Now third thing is git push. Git push basically uploads your commit to a remote repository like GitHub. So you are sharing your changes with collaborators or backing them up online. Okay, so how do you do that? Git push origin main. You don't have to write origin main every time. If you are in a default branch, you can, if you want to specify a branch, you can do that. If you want to work in your default branch, then you can just write git push. So what is the analogy there? Publish your saved changes to GitHub so that you can compare it later on. Okay, so far so good. Now I wanted to tell you one more thing about GitHub. I have not talked about the collaboration so far. Okay, when you open your repository, you go to setting and then you see collaborators, right? So what you can do, you can create a repository and you can invite collaborators like me, like your peers. So we will do that. So we will create a Git account. I will give you an assignment. So you basically can add people. So you can find them by their username. So whatever they have registered with on GitHub, and then you can work together in a single repository. So sometimes you do commits, sometimes I do commits. So it is kind of a collaborative environment. So we will do that. Okay, this is how you do it. Okay, so far so good. One other thing I wanted to tell you about VS Code, which I just remembered. Okay, so here I am creating a copy of this thing, okay, and I am pasting it here. Okay, now I have two files, py underscore code copy.py, py underscore code.py. So in one of the file I deleted something, right? I deleted something, and now I want to compare these two files. So in Visual Studio Code you can also do that. How you can do? You can right click on here and you do select for compare, and when you do that and you right click on the other file and you say compare with selected. Okay, when you do that you can see side by side both of the files. What is the help, what is the utility of this thing? Basically you can compare your files, you can see side by side what changes I have done within the two codes. These are very helpful while comparing two codes in a local machine. And you can also use git diff if you wanted to compare it with the cloud. And there is also a very important tool, online diff checker. Okay, so if you go there and what you can do is copy, okay, not this, let me just copy this, okay, and I go back to my this, I put it here, I put it here, and I deleted something, right? I deleted something here. Now I go down and I put find difference. Okay, so it can basically compare both of the code and will tell you about what are the changes in the previous version or in the next version. So these are very helpful tools. So initially I used online diff checker, now I am more used to VS Code. Okay, so far so good. This was all about GitHub. There were some problems in the beginning, but okay, we figured it out. So do you have any question about this session so far on about GitHub? Are you good with it? Okay, very good guys, thank you very much. Now let's go to quickly to LaTeX session, right? It will not take much time. LaTeX is, I'm not gonna teach you step by step. And if you are bored, like we are talking about this thing for straight 1 hour, if you want a break, do tell me, I will be happy to give you a break. But I think I will not take much time, it will just be 15 or 20 minutes. So LaTeX is comparatively easy. Okay, so let us go to our LaTeX thing. So I told you about creating an account in Overleaf, right? I hope you have already done that. Okay, let's do this. Okay guys, introduction to LaTeX for scientific documentation. So LaTeX is a language, okay, it is a typesetting system designed for the production of high quality technical scientific documents. It is pronounced as LaTeX or LaTeX, okay, it depends upon your pronunciation and accent, but it is not LaTeX. Some people do call it LaTeX, it is not that, it is LaTeX. So it is based on tech typesetting engine developed by this guy in 1970s, and LaTeX allows you to focus on content while it takes care of the formatting. So in word processors you have to put a lot of effort to make your thing, whatever you are writing, make more visual. You have to put more effort in while formatting. I don't like it, I don't like Word, sometimes I struggle with it. But in LaTeX you just have to write your code as a text, whatever you wanted to write, you have to write it as a text, and then it will render the PDF for you. Okay, it will render a well formatted PDF for you. So I will tell you how. You have the example in front of you at present. So why use LaTeX? So LaTeX is especially suitable for documents that include mathematical equations, because it gives us very hard time to write equation in Microsoft Word or any other softwares. So, LaTeX is the first choice whenever we want to write some mathematical equations or scientific symbols, and also bibliography and references. It is very helpful to manage bibliography and references. Also, what about figures, table and captions? Okay, it is also very good with that. In word processor, it is very tedious to do that. You have to do everything manually. Then we have cross referencing and indexes. It is very powerful. I will tell you about that, like what is cross referencing and indexing. And then we have it is widely used in physics, mathematics, computer science, engineering, academic, publishing. But I have, how do I get to know about LaTeX? I started my research and I started writing documents in LaTeX for my research papers. Actually, I have never seen a person like in computer science, engineering or even academic publishing who are using LaTeX, but they use, but it is very common in the physics section. So, people physics people love it a lot because it has mathematical equations. They have a lot of mathematical equation and they need to have some very good typesetting software that can render the mathematical equation gracefully, right. So, we will talk about that. So, what are the advantages of LaTeX over traditional editors? So, what are the traditional editors? Traditional editors are word processors like MS Word. So, let us talk about one feature at a time. So, let us start with the equation formatting. Okay, in equation formatting, I told you like it is precise and very professional. But in word processor, you will see when you go to Word, you go to some equation tab there and you click on one equation one by one, and it takes a lot of time to make that equation work, make that equation, you view that equation in your word processor, and the final output is not also very good. It is clumsy and inconsistent. What do I mean by clumsy? I will tell you. See, whenever you write a mathematical thing in LaTeX, mathematical equation in LaTeX, the final output is very good, very precise, it has a very good contrast and it is not blurred. But in Word, it look blurred. And then we have citation management. In LaTeX, we have automated it with BibTeX and BibLaTeX. But in word processor, it is usually manually, like you itemize all those things or you use some plugin like EndNote, Mendeley, all those things. Mendeley and EndNote also make it work, but still I don't like it. I have never written a research paper in Word. Cross referencing, it is very good. What do I mean by cross referencing? I will show you a document, it will be helpful. Cross referencing is like I am describing a figure and I am citing it. Obviously, whenever I am writing a resultant discussion, I will be referring to that figure again and again. So, there should be some hyperlink so that I click on that button and I go to that image. Okay. So, cross referencing is automatic and consistent in LaTeX, but in word processor it is not. Version control. In version control, you can do version control, you can put your text file in your GitHub repository and you can do version control. But in word processor, it is hard because it is not a coding based thing, it is not a coding based typesetting document mechanism. Therefore, it is not able to, we are not able to track it, right. So, it has a separate mechanism inside the word processor where you can track it locally or on the cloud. So, we have cloud versions of word processor like Google Doc or Microsoft Word. Then we have document structure. LaTeX is very easy to manage large projects. It is very easy to manage large projects such as thesis, right. And word processors are difficult to scale. If we are dealing with 10 to 15 page document or maybe 50, it is fine, but if it is like 300 page document, it is very tough to handle it. Sometimes words it takes a lot of processing and the computer also gets hanged when we are dealing with it. Then we have output quality. The output quality in LaTeX is very good. So, the print ready PDF is with full control, but the word processor, one thing is the formatting, the final formatting, it does not look that good. and also the rendering contrast. If you talk about colors, contrast, it is also not good. Okay, so this is the advantages over this is the advantage of LaTeX over traditional editor. And I would also like to emphasize one thing here. So you can do version control with Git, but in Overleaf you have this button here, history. So when you do that, and you can also collaborate, right? This is also very important. You can share, I can put your email there, right? When I put that, we can edit this document together like we did in Git. Okay, so if you do some changes, it will reflect here whenever you do some changes. So it is very useful to track the changes whatever we did. Okay, and you can also put a label like a comment. Okay, so this was the thing, and now let's do the splitting. No, not yet. Okay, let's stick to our PDF only thing. What is the basic structure of a LaTeX document? I told you it is a coding based thing. So on the left side you have an editor, right? It is like left side you have an editor, you have this editing window here. So whatever you write here, you hit recompile, and obviously LaTeX, like other languages, for example Python or any other thing, we have LaTeX compiler installed in Overleaf, cloud based, and whatever you are writing, whenever you hit recompile button, it basically renders, it basically compiles it and it displays it. Okay, so what is basically happening here? So you are writing the code, your code here, and it is displaying here. So the basic structure of a LaTeX document goes like that. So there is a you have to define a class of the document and the font size you are interested in. The class could be anything, it could be article, it could be a research paper, you can call it, like if you are using some journal, some specific journals, they have some specific class. So the basic class I would like to talk about is article. Then we have Beamer class. Beamer is for presentation, we will talk about that later. Then we have packages. So packages are nothing but, like in C++, whenever you want to do something fancy, you want to deploy special power to your machine. For example, in Python you want to use NumPy, you cannot just use NumPy, you have to write something import NumPy. So for that, if you are writing import NumPy, or if you are writing using namespace std, you are giving some instruction by which the code can execute some fancy thing, right, some special feature. So similarly, when we do use package or some particular package, it is giving your LaTeX code some special power. If you do AMS math, it has some special power, it can display math. If you do AMS symbol, it has some special power, it can display math. I will talk to you more about that. So packages are some libraries, you can think in terms of that, which are helpful to access some special features. Then you can define your title, you can find your name, author, date, and this is where the main document starts. So you basically, this is a preamble, this is called preamble before the document, where you basically load all your settings, all your libraries, and all your nomenclature, like what this document belongs to. And then we start with begin document, then you put make title. When you do make title, it basically display your title information there, like title, author, date, and then you start putting information in your document, and then at the end you have to end your document, because in programming whatever you have started you have to end it, right? In C++ it is the semicolon, in Python it is the indentation, but in LaTeX it is begin and end. Whenever you are using a such environment, you have to start like this, begin something and end something, so that the compiler knows what it has to execute. Okay, so on the left side, this is the whole code. You don't have to worry about remembering anything. If you are not familiar with it, you don't have to worry about. These are very trivial. You don't have to learn. Nobody is going to ask you, okay, what is the how would you create a LaTeX document? You have AI tools for that. You can just whatever you want. You should have some basic understanding, by the way, okay, how the things basically works. So let's go to another project which is I have created, introduction to neutron stars, and I also have shared it with you. Okay, if you go to LaTeX here, I have shared all the documents with you. I have shared that LaTeX text file for two different documents and PDF as well. So you can download it and you can create a new project on Overleaf with these documents. Okay, let's go back to the Overleaf. Okay, so this is the document, and on the right side we have the rendered version. So okay, let's go through this first. So guys, you can see how beautiful the final structure is. You can see the color, you can see the formatting. I have not done any manual thing like putting a space here so that it is centered, and I am not making it so it is always in center. The left and right margins are exactly same because this is a programming language. Then we have various environment that we can use to structure this document. For example, we have abstract environment, we have section environment, we have itemized environment, we have so many things. Then we have equation. You can see how beautifully it has rendered this equation. It is like it is embedded within the document. But if you compare it with the word processor, you will feel that somebody has written on the paper, like it is kind of clumsy and blurry. So I don't like it. Then we have also again the equation. Look how beautiful this equation is appearing, right? And these are the section. Then the tables are also very important, and you can customize it as per your need. This is the simplest table, and look the output, it is very good. And then we have figures. You can put figures in your document. Okay, and then we have references. Right now I did not include bibliography, bibtech basically here. So the bibliography has been put by a simple manner, like using itemize. So let us go through this code. This is a very simple code. So I will just give you the overview. See how do we start? We just start with the document class, and we declared a font size, and it is an article, which is a by default class in the LaTeX. What it does is sets the document type and font size. Okay, so again I will tell you, you can use any class, article, PRD, APS, anything. It depends upon the journal. They have made some custom class in LaTeX, or you can also use Beamer. Then we have packages. Packages are the libraries, packages that you need to execute something, some special feature. For advanced mathematical typesetting, if you have some advanced mathematical thing, like you want to display derivatives, you want to display some special symbols, you have to include these packages. And then if you want to include the images in your document, then you have to write this. If you want to do caption customization, this is the thing. If you want to make your document like clickable, so if you put some URL link and you want user to click that particular line and it should open that particular URL, then you have to use hyperref. So you are basically embedding a URL in your PDF. This is how you do it. Then we have geometry. So if you have this package, you can customize your margins. For example, right now the margin is 1. Let me do 0.5 inch and do this. So if I do that, the margin will change. Okay, now the margin has been reduced. So you can see, you can control the margin. So I will just switch it back to 1 inch. So this is, so we are changing margin. By this we are changing margin for all sides, like left, right, top, bottom. But if you can also customize it for left, right, top and bottom individually. Then we have title, whatever you want to print. Then we have date, then we have author. So this is so far the preamble, that's it. So you can load more packages, you can load more information in that as per your need. So this is the basic thing. Now if I don't put make title here and I render it, you will see there is no title. So the information we provided is not being displayed. So how do I display it? I have to put make title. So make title displays it. Now we started in the main environment, which is the document, and we started the abstract section, so which is that, and we put some text in that, and then we created another section, which is how you do it. And in LaTeX there are several ways you can write an equation. One is called inline mode, inline math mode, where you can write your mathematical equation in the line. For example, like this, what you have to do, whatever math you want to display, you want to put, you have to always write in the dollar sign. If you do that, it will display correctly, otherwise it will create a mess. Okay. Now, then we have these special symbols, you have to remember it. For example, I have this solar mass sign here. Okay, so I have this solar mass sign. How do I put it? There is some encoding behind it. So what is the encoding? Backslash dot. When you write that, it basically displays that. So some of the things you have to remember, and you don't have to remember, you have ChatGPT for that. You just ask, I want this symbol, I want to display that symbol in LaTeX, it will give you something. Then this is the thing, how do you itemize the thing? Like if you want to put things in the items, or in a simple manner you want to create some bullet list, then this is how you do it. You can also use numbers instead of bullet points, right? It depends upon you. You can also change the counting, that is something advanced, you can figure it out later on. Then we have new section, and this is how you put a equation. So it is written in fancy way, I will just write in a beginner level way. Okay, I missed that. Okay, so begin equation, and then I will end equation. So it is the same thing. Okay, so when I do that, so it basically does that. Now you can see there is a corresponding equation number. Okay, and I can also label this equation. How do I label this? I do this, I put like EQ, let us say pressure. Okay, so I do this, it has been labeled. Okay, now I will tell you about cross referencing. So cross referencing is, this is equation 1. So this is a one way to write it. If I wanted to refer my equation at a later stage, like how can I tell my reader to go to that particular equation? So one way I can do that. Other ways is I can write ref, and I can put the label here. Okay, when I do that and I render, and when I go to this one, I mean I put my cursor here, then it is showing some hyperlink, and if I click on that, it will take me to this particular equation, right? So this is how we do things. And then we have a fancy way. I don't want to write equation, I want my LaTeX to do it itself. Then I change my ref to cref, which is cleave ref. But to use that, okay, let's do that. Let's compile it first. When I compile it, it basically complained. It doesn't understand what cref is. Okay, it doesn't understand what cref is. So that means we are missing something. Either we have done written some syntax wrong, or we are missing something. So to use cleave ref, cref, basically we have to load the package cleave ref. So when you do that, you go to your line, this line again, and you can see I don't have to write equation here anymore. So it automatically judges, it automatically put the equation in the bracket. Okay, and when you click on that, you again can go to that equation. Okay, this is the power of LaTeX. This is the cross referencing thing I am talking about. So after this document, I will show you my research paper. I will give you some examples, just the PDF. And then we have TOV equation, which is displayed, and we have bullet list again, itemize, then we have section, and this is the equation I am talking about. Okay, so you can see the final output of the equation on the right side, but on the left side, this is this is a code that you have to remember, like how to write fractions in LaTeX, how to write fractions in LaTeX, how to use special symbols in LaTeX. This is something you have to learn. Okay, it will not take much time. You can always do ChatGPT or Google, and you can give equation. You can tell that, okay, I want to write this equation, and if you are not able to find it on the internet, you have to write it by yourself. I don't think it is a great task. It is very simple. Then we have what else? I told you about table. So if I go there, okay, this is the table. This is how you write table. Okay, you just have to look through it. You define a table which has some custom float variables. I will not talk about that right now. And centering is which makes it centered. And then you basically start your table, and you put your how many columns you need. Do you want vertical lines or not? These are the vertical lines, right? If you want that or not, all those things. Then you want horizontal line or not. These are the horizontal lines, and these are the vertical lines. Okay, if you want that or not, and you put math. Since this is an inline math mode, you put in the dollar sign, and is basically this ampersand is basically telling us it is differentiate between two columns, right? So that the LaTeX know, okay, after this there is new column, there is new column, there is new column. And this ampersand in equation in the align environment, it is also used for alignment, which we will talk about in a more comprehensive manner when we touch some deeper details of LaTeX. Okay, now then we have figure. Figure is very easy. So you need use package graphics for that. So begin figure, again the float variables, I will not talk about that right now. The thing is, you have to put include graphics, then you have to put your file name here, and make sure it is in the root directory. If it is in the root directory, then it is fine, but if it is inside some folder, then you have to put a whole path here, right? And then you can scale it. You can change the scale. Let us say I do scale 1. Okay, what will happen? Let's see. So right now it is 0.25. If I do scale 1, oh no, what happened? This is a lot. I don't want it, right? I have to make it adjustable. So by fine tuning, I just make my figure fit inside this document. Now it is way better. And then we have caption. You can see a beautiful caption here, and you can use also label. Okay, you can label it. You can do, okay, FIGNS, this is a good label. And as we did for equation, you can also use the cross references like reference or cleave ref to go through the document here and there. You can cite this figure later on anywhere else. Then we have conclusion, which is a simple section. Then we have references. For the time being, it is just I have displayed it like a normal list. So we will talk more about bibliography in the coming sections. Right. So this was a short introduction about LaTeX, just a motivation like how things works. And I would like to show you my documents now. Okay. I can show you my published one. Maybe just the PDF. Okay, so let's go to Zotero. Okay, my papers are here, but the PDFs are not here because this is a cloud based thing, but in my local machine I have the PDF. So I go to my papers, and let's do some, which one? Okay, let's do this. So when I open that PDF, it has been written in LaTeX, right? So you can see everything is written in LaTeX. So what we did, for example, there are some references. You can see how beautifully this has been organized. I mean, can any word processor put this equation like that? No, it's not gonna happen. So these are the references I am citing. So there is a way how to cite it, but I will tell you the basic things here. So for example, I am defining some tables, some equations, I am labeling them, all those things. So these are very beautiful equations. And then okay, let us stay here. So I described, I put an equation there, and it has some variable. Now in the next line I describe what are the variable. These are this, but I wanted to point it out that this variable has some meaning. Okay, it has some structure, mathematical structure, and I am referring it, it has been written somewhere else because I don't want to put all the things here in my main document. So I basically created a reference. Okay, whenever I click here, I go to that particular location, and it is in the appendix. So this is how in LaTeX you can travel through the document, and also you can see there are very good figures. So you can embed your figures, and you can see these figures have been made in Python. This is in MATLAB. These are in Python. matplotlib. When we talk about matplotlib, we will go through that. And what else I want to tell you is the figures. So I am writing discussion and I want to go to that particular figure. So this is where we use hyperref, right, cleavref or any sort of referencing. So I click it here, figure 4, I go to figure 4. So this is how easy it is when you use LaTeX. Okay, the documentation writing is very easy. Okay, but it is tedious. It look tedious to a new person. A new person always prefer Word over LaTeX, but eventually when you are used to LaTeX, you do wonders. You don't want to switch back to Word again, maybe for simple stuff, but not for the stuff like this, because the final output in LaTeX is very good. Okay, so this document I was showing was of 60 pages, and if you are also interested in like big, does Overleaf, okay, I will come to you, I am just finishing. So it can also manage theses, right? I think I must have it somewhere, but I don't have LaTeX installed in my local machine, because the moment Overleaf started, I become lazy. Now I don't do LaTeX on my local machine anymore. But when I was in my PhD, I wrote my thesis in LaTeX. Manuscript thesis, yeah. So this is the thesis, and there should be a thesis sample. no. Okay, so this is a thesis sample. You can see there are a lot of files in LaTeX. There are figures. I was not that much organized before, but now I am. So we are only interested in .tex file. Okay, we are only interested in .tex file. So can I yeah, .aux I don't care. These are just documents, I don't care. Then log file, yeah, tex file. So there are several files in my thesis file, and there is a main document, right? So you can handle a task like thesis, which is a very substantial one in LaTeX, easily, and you can just click a button. It will do wonders in 5 seconds only. Okay, it will not take much time. So it also depends upon how much figures you have, but it is good, it is very good. Okay guys, that was so far about the LaTeX session, and now I will come back to you guys, and if you have any questions, let me know. Let me read. Does Overleaf give full access to packages? Because I see there is a premium version. Okay, that is a good question. Also, does hyperref work when your reader is using regular text reader to read? Like, what text reader are you talking about? Okay, let me answer your first question. Okay, this is a very good question. See, okay, I have to share my screen again. So far, Overleaf doesn't constrain you with the packages. You know, LaTeX is open source. Overleaf cannot control the packages. LaTeX is open source by its creator. Overleaf doesn't own it. Overleaf has created an interface. They can control that features. So what they can control is the speed. So they do that. So if you are dealing with very normal documents like 5-6 pages, or maybe Beamer presentation of 20-25 pages, and the figures are not heavy, like only 10-15 figures are there, it is fine, it will run very good. But whenever there are figures like 20-50 figures, and the documentation, the rendering time will get affected, right? In that case, in the free version of Overleaf, they only provide you a limited compile time. I mean, it is not about limited compile time, how faster your compiler can run. If you have a substantial document, then your compiler will fail if you are using a free Overleaf version. That will not gonna happen to you guys, because we are not going to do create any significant document here. If we are going to write thesis, maybe it will complain. Yes, it will complain. So this is the one complaint about Overleaf. The second complaint is related to the premium and free version. In free version, you can only add one one collaborator, right? Only two collaborator can edit simultaneously. But if you have premium version, you can create as many editors you want. Okay, so this is the thing. Now I hope I answered your question. Honor, first question.
Yes, sir, you answered my first question.
Okay, now about next question. So I have never came across such problem, but okay, let's go there. And I download this. When I download this, when I click this, I open this in my Google Chrome. Okay, let's see if it is working. It is working. The hyperlink is working. If it is working for label, it will be working for any URL, right? I have not put any URL here so far. Now you can also open it in your Adobe Reader. Why do you say text editor? Are you maybe I am confusing it with the PDF editor. Let me read your thing again. Also, does hyperrough work when your reader is using regular text reader to read? It should
That
not.
is what I mean. Like if they are reading with WPS or Microsoft and they click on the hyperref, will it work? That's what I was asking.
It should work. If it is not working, that is something. The problem is with the renderer, the PDF renderer. It is not with the LaTeX. So you can switch your PDF. So for example, in Mac, I have preview and it works very good, and it also works with the what was that, Adobe Reader. It also works very well. Okay guys, do you have any more question? Okay, you don't have any question. So I like this session a lot, especially the LaTeX one, because I like this language very much. So don't worry if you are new to LaTeX. See, you don't have to learn everything on one day. So whenever you are doing something, we are learning day by day, and whenever you start doing your actual assignment, whenever you start working on your presentation, you will get to know that. And you have, again I will say, I will not uh, um, I will not ask you to not use ChatGPT for that. I mean, you can use for LaTeX. You don't have to give any exam for that. You don't have to develop any understanding for that. You can do that. But as long as you are learning it, it is not like you are not putting it mind into. For example, whenever I do ChatGPT, I just don't copy paste it. I put some comments here so that I know what is the meaning of that particular line. Okay, I want to be smart. I don't want to be dumb. I want to use AI tools, but at the same time I want to know what is the utility of that. Okay, I just want to know what is the utility of package. I don't care how many packages I load, as long as I know what is the meaning of that particular package, right? So we have to be smart. We have to use the AI tools carefully. Okay, last but not the least, I am going to share you a very good tool that you have to do the assignment. Okay, for example, I want to write this equation in my, I saw this equation somewhere in the PDF, some research paper, right? But it gives me a very hard time to copy it, to write it manually. I have to do dp by dr, fraction, all those things. It is very tiring. So what I will do, I will be smart. I am smart. Okay, then I will use some tools. So what are the tools I am talking about? What is the tool I am talking about? Is MathPix. You can install it. Okay. Right now it is not displaying because I have so many things open here. So it should display it somewhere. How do I overcome this problem? Can I get rid of that? Okay, it should display. How do I do that? Maybe I have to turn off my screen for a bit and then share again. Okay, no, it is not happening. Anyhow, it is not happening. Maybe I will share a screenshot with you, because I can only access it if I can click on that tab, because I have so many things opened here on the top, it is not showing me that. So I will share the screenshot. What you have to do, it is like a screenshot app. You have to install this thing, M.R.P.D. Okay. So when you install that thing, okay, and you can take a screenshot of your PDF. I will create a video and I will show it to you, okay, later on. It is not working right now. So that was so far about my presentation, guys, today. I hope you like it. If you like it, give thumbs up. If you don't like it, give thumbs down, okay. So so now tell me, do you want a discussion session today or not? What do you think? You want to try GitHub, Git, all those things by yourself, or you want to discuss with peers? Okay, let me tell you one thing. I am not gonna join the discussion session today. I have to go somewhere, but you guys can interact. You can guys can create links. You can guys can say, distribute yourself among different groups, and you can learn together if you want. So this is very optional today. Okay, and next week is gonna be very good. It is traumatizing for me because I have to prepare a lot. Okay, let me just show you. I will just take 5 more minutes, then you are done for the day. I have said it many times in this presentation. Okay, let me go to my, what was I doing? Okay, so I wanted to go here and there. Okay, so next week is gonna something, we have to work a lot. So we will be touching the real Python next week. We will be doing some extensive coding. So I will also give you some good task, and it will be fun. Whenever we start using NumPy and pandas, it is fun. So we will be doing with Matplotlib, we will be plotting all those things. So I am very excited about next week, and I am also a little bit traumatized, like I have to prepare a lot, but I hope you guys will like it. And next we will also discuss how to create CV in LaTeX. So we will not do it by scratch. We will just start from, we will take a sample document and we will do all those things, right? So I think that's it. I wish you the best for this, the remaining of this week, and take care. Okay.